Welcome to this Nordic partner webinar. Today we have with us Edge Impulse, and we are going to talk about how to power the next generation of IoT with embedded machine learning. So my name is Petter Myhre. I'm head of product marketing at Nordic Semiconductor. I've been with the company for over 7 years now, and I lead a small team responsible for product launches, webinars, blogs, and promoting our products, making sure that we give our products the right promotion. And we also today have with us Sin from Edge Impulse. Hi Sin, maybe you want to introduce yourself?
Yeah, hey everyone, it's a pleasure to be here. Thanks for your time. My name is Zin Shaw. I'm a senior user success engineer with Edge Impulse. My role is to work with our partners, developers, our wide community to help them be successful.
Thank you. Thank you, Sin. And I always have to go through some practicalities. So the webinar will last approximately 60 minutes. We will try to keep it inside that so that if people have meetings afterwards, they will be able to see the whole event. We encourage you to ask questions. Please use the top right sidebar to do that, where it says ask questions. All questions are anonymous, and also we hope that we can try to keep it relevant to the topic. We will answer questions towards the end. Then I just want to say that the chat is not anonymous, and please do not use that for questions. And if your question didn't get answered, or you want to have more information, you can reach out to us through DevZone, or you can send an email to hello@edgeimpulse.com for questions to Edge Impulse. And also always, a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com.
All right, background on the state of the IoT to start with, as well as introduction on how embedded machine learning can make our systems and devices smarter. Then we'll dive into a quick intro on Edge Impulse, followed by our excellent collaboration with Nordic. And then we'll go right into a live demonstration. And then, of course, we'll wrap up with a Q&A session at the end for about 10, 15 minutes or as time permits. Definitely would love to have your questions in the question box, as Petter mentioned before. So let's take a quick review of the state of the IoT. Typically today, measurement samples are sent continuously to either the cloud or a gateway, where most of the rules, logic, and machine learning sits. So most of the analysis is performed there to gain meaningful insights. However, this traditional technique runs into several challenges when, for example, the system's cloud connection is bandwidth constrained. As you guys may know, many deployments are using low bandwidth connections, such as LoRaWAN or cellular IoT, for example. So every byte, every bit is precious in terms of how much data you send up into the cloud. Sensors are also, of course, power consumption constrained. There are many applications out there where these sensors need to live on batteries for 10, 15, sometimes even 20 years. For example, gas and water meters that go into the ground. And so it is extremely important to conserve power wherever is possible. And then last but not least, we have sometimes latency introduced in the system itself. Now, generally, when we think of sensors, edge sensors, for example, temperature sensors, generally they're reporting every half hour or 1 hour on the clock. And so you might not think that that's a lot of data being sent. But when you multiply that by the number of sensors there are deployed out there, let's say 1 million sensors, then all of a sudden the amount of data that gets sent to the back end is tremendously large. And the compute and latency that's required to process all that then starts to manifest itself. And so if you can avoid some of those challenges, then you can also save a lot on bandwidth as far as and costs as well. So this is where embedded machine learning can help. We can address these challenges by leveraging embedded ML on edge sensors powered by your favorite Nordic device, of course. And so the technology around embedded machine learning now has come such a long way that it is now even possible to perform real-time, low-power inferencing with even a Cortex M0-based MCU with minimal resources on RAM and ROM. Instead of just continuously sending raw data measurements to the cloud, we can instead turn around and send only those meaningful insights, which will be much more efficient for the system to do so. So by harnessing on-device intelligence, we can, for example, detect different kinds of anomalies. For example, if temperature varies in a way that the device has never seen before, we can actually use embedded machine learning to detect outlier measurements, as you can see here. We can detect, whether there's a vibration pattern that would lead to a fault state down the road. So this fits very well in terms of the theme of predictive maintenance. Or if a machine oscillates differently than all other machines in the factory for some reason, perhaps it's starting to break down, we can use embedded machine learning to handle these kind of cases. As engineers, we can then now use a data-driven approach by using the ML model to, by using embedded machine learning to model the behaviors and signatures that we see in the field, run inferencing at the edge, and then send, as I mentioned earlier, the meaningful conclusions to the cloud. This allows us to save energy, save bandwidth, and ultimately save costs. By doing this, we will design more efficient systems and as I mentioned, save energy, bandwidth, and ultimately save costs that would normally be incurred by processing all of that raw data in the cloud. And if we look at the application space where we can combine the powerful combination of IoT and embedded machine learning, this really interesting fusion of these two technology spaces, really the application space is unlimited, which is very exciting. But we do find a lot of the killer applications in these three different categories: one of predictive maintenance, asset tracking and monitoring, as well as human and animal sensing. But you name it, from smart city to cold chain, logistics tracking, asset tracking, to health, smart health applications and wildlife conservation. The power to unlock values from all these application spaces exist when you combine IoT and embedded machine learning. And we're really excited for what everyone is going to create using the combination of Edge Impulse and Nordic. So most people, when they think of machine learning, they think of machine learning as a silver bullet, a magic wand, you wave it, and magically you solve all of the world's problems. However, as engineers, we think of embedded machine learning as another arrow in our quiver, another tool on our tool belt to help solve the next challenges in our IoT applications. This is exactly where Edge Impulse comes in. We're providing you a complete one-stop shop with an awesome end-to-end user experience for deploying your embedded ML solution. Gone are the days when you had to use disparate tools to acquire the data, train your data, to develop a machine learning model, validate and test it, as well as then deploy it onto your embedded device. So now you have a really easy to use, seamless tool, as well as secure, that will allow you to manage this embedded ML pipeline from start to finish. So I mentioned you can use our Edge Impulse Studio, a portal, to manage your entire embedded ML pipeline. This allows you to easily and securely acquire data from your devices for your data sets, design, train, and validate your embedded ML model, what we call the impulse. by using our built-in signal processing and machine learning blocks. And finally, of course, deploying optimized embedded code at the edge. We have a special Eon compiler that goes beyond the efficiencies of what TensorFlow Lite Micro can give you. And generally, we see about 25 to 55% savings in RAM and ROM usage as a result of directly deploying to embedded C, C++ code. So what you see on the right here is also some output from the Edge Impulse Studio, where you can also get instant analysis on how your model is performing and what kind of resources will be utilized on your embedded device. For example, you can see here on the right-hand side, these are actual numbers from our audio classification demo that we'll show you later on. So very minimal RAM, very much minimal ROM usage, and it can even get lower than this depending on your application. For example, if you're doing just a very simple measurement and sensing application, these numbers get even lower than what you see here. So there are many ways to ingest datasets securely into Edge Impulse. At the core of making embedded ML work for you in your application is, of course, making sure that your datasets are robust. We've made it easy, seamless, and secure to import your datasets into the Edge Impulse Studio. There are various ways to do that, as I will show in the demo and walkthrough later on. You can use our built-in command line interface tools, even use your mobile phone or PC, and upload existing data sets that you might have in your own various bit buckets, for example, like from AWS, Azure, or Google Cloud. Edge Impulse allows you to also enable enterprise collaboration with embedded ML ops. ML ops is actually now an actual discipline combining the best practices of DevOps as well as machine learning. And at Edge Impulse, we are answering the bell in terms of how, as an enterprise, you can have a seamless workflow that allows your teams as an organization to manage your embedded ML projects. So for device makers in an enterprise environment, we offer you the tools necessary to seamlessly collaborate with other individuals within your organization, cross-collaboration across teams, to perform iterative development for continuously enhancing the performance of your embedded ML model, as well as be able to seamlessly track and manage your deployments. So, we're thinking of this as a complete life cycle throughout the development phase, and you're always, acquiring new data, testing it, revalidating it, and see how you can improve your model. Now, let's look at some of the case studies that we have empowered with Edge Impulse and Nordic. First, we're making health smarter with ML. We partnered with a leading wearable health device maker to accelerate the research and deployment of new sleep and flu onset detection algorithms. Our enterprise features empowered them to set up a full embedded MLOps pipeline. This really allowed them to perform iterative embedded ML development through cross-functional collaboration, as I mentioned before, and literally saved them man years for deploying new embedded ML algorithms. Next up, making the grid smarter with ML. We partnered with Ernest and Nordic on a solution that enables remote monitoring of power grids and devices called surge arresters. These are surge arresters are devices that protect electrical power equipment from overvoltage transients caused by either external events such as lightning or internal switching events. Embedded machine learning with Edge Impulse provides the ability for the system to gain insights by way of the different sensors on the board, as you can see here from this RAM1 device that's featured here. And we use that data to then perform anomaly detection using our embedded ML algorithms. Being able to only send the insightful conclusions to the cloud enables the device to achieve a 10+ year battery lifespan in the field. This device uses the NRF 9160 and NRF 52811 combination The NRF9160 is primarily used to establish cellular IoT connectivity, and the NRF52811 is primarily used for easy commissioning through BLE. It can also be, of course, used in the event that the cellular connection might not be available to collect data. Last but not least, we're also empowering wildlife conservation with embedded machine learning. The Elephant Edge initiative inspired a plethora of projects to help elephant conservation and fund the development of the next generation elephant collar, which would, of course, see the fusion of IoT and embedded ML at the heart of those innovations. Edge Impulse provided the embedded ML program, embedded ML platform to leverage sensor data from devices such as the elephant collar, allowing researchers to understand more about how elephants behave in their natural habitats and respond to external threats, such as poachers. Elephant Edge is, of course, only one example of wildlife conservation, as there are many animal species in the world that are endangered, where embedded machine learning could lend a hand. For this application, the NRF52840 was used. Diving into our Edge Impulse collaboration with Nordic, what we have done with Nordic is made a slick end-to-end user experience to be able to deploy embedded machine learning on the NRF52840DK as well as the NRF5340DK. So we've come out with fully supported standalone inferencing example projects that are NRF Connect SDK based. This is based, of course, on Zephyr OS. You can use these with the Edge Impulse data forwarder tool. This is a command line tool that allows you to perform data ingestion over a UART protocol and securely import that into our studio. You can train your models in the Edge Impulse Studio and then build downloadable binary images that use the MEMS microphone and MEMS accelerometer on the X-Nucleo shield board that we'll see in a second. So what we will demonstrate in a little bit here is actually two demos within a demo. One is audio classification demo, where we'll detect different bird sounds between a house sparrow and a rose-ring parakeet. And then we have a traditional gesture recognition demo that uses the 3D accelerometer. And we'll also be able to, one piece of exciting news here is that we'll also be able to show those results streaming across BLE using the Nordic UART service and the application, the NRF Toolbox application that you can download on your Android or iOS device. So how do you get started with Edge Impulse and Nordic? You can sign up for free at edgeimpulse.com, and there are some various entry point tutorials that would be a great start for you. One for each development platform, and there are also documentation articles on the NRF SDK documentation, as you can see here. One of them uses the data forwarder, which I mentioned allows you to import data across the UART connection. So this is a really easy way of getting any kind of measurement and sensing data up to the Edge Impulse Studio. Would like to point you to some additional resources as well. So we actually recently launched a Coursera class for Introduction to Embedded Machine Learning, which uses the Arduino Nano 33 BLE Sense. Again, this device also is preloaded with examples for audio classification and gesture recognition. But as you can see here, there are a plethora of different types of sensors that you could leverage. You could also try using other external boards, of course, like the BME 280 temperature, pressure, humidity sensor from SparkFun, for example. But really, as I mentioned before, using the data forwarder, you can acquire data via UART on any Nordic-based device. The NRF52833 is also featured on the microbit, where we have an example for that as well. And the demo that we're going to show you today is also downloadable for you to try on GitHub. So you can check this out there. It works for both the 52840 as well as the 5340. So before we dive into the demo, once again, we are Edge Impulse. We hope you'll give us a try. We're a world-class team of industry leaders and embedded experts, hoping to offer you a very delightful experience when you're using our studio to deploy your next generation IoT applications. We have over 8,000 developers, 13,000 projects, and over 9.5 million data samples already ingested into our studio, with those numbers growing every day. So real excited to see what solutions everyone will make out of this. And with that, let's dive into our demo. Okay, so the first demo is an audio classification demo. As I mentioned before, we'll be able to use the dev kit to essentially sample audio data. In this case, I've just pulled up a parrot calling sound video from YouTube. And so we'll be using this little guy to see if we can test our model that we've developed within Edge Impulse. The very first step, of course, is acquiring the data sets. So we have this data acquisition tab where you can establish your training data set as well as your test data set. And as I mentioned before, there are multiple ways of getting data into Edge Impulse. As you can see here, you can use a fully supported development board like the 52840DK or the 5340DK. Even your mobile phone, with a simple QR code scan, you can actually have that recognized as a device and get data from there. As your cell phone is, of course, equipped with many sensors already. Data from any device using the data forwarder that I mentioned. So as long as you have a UART connection, you're good to go, and you can actually connect that device through our serial daemon and acquire the data into Edge Impulse. If you've got static data that's already available from your PC in these various formats, you can, of course, upload that as well. And then for our enterprise subscriptions customers, you can also integrate your various bit buckets that I mentioned before with our Edge Impulse Studio. So once we have established our training data, and for this, we basically have three classes, one which is just noise, and the other two classes that we're actually interested in are the rose ring parakeet and the typical house sparrow. We've labeled all of the data accordingly as well, which is very important as well. Once we've established all of that data, we go to our next phase of the process, which is the impulse design. And for here, what we're going to do is establish basically a sliding window of the data set. So essentially, we can take that, for example, 8-second piece of audio data and basically overlap that with a 500 millisecond sliding window and actually produce more data for our neural network to train on rather than just the data sets we have uploaded. We can then add a signal processing block. And for audio, we typically use MFCC, which are Mel frequency substroke coefficients, great for analyzing voice. But you can see here that we have a plethora of different signal processing blocks for different applications, for example, for image processing or other processing blocks for measurement and sensing. So we'll select MFCC for now, since we're doing audio, and that's already pre-populated here. Then we get to add a machine learning block. And typically we have three basic ones here. So we'll use a neural network for the audio classification. For image recognition, we go with transfer learning, and here we use a MobileNet model for that. And for anomaly detection, this is really good for like analyzing temperature sensing data, for example. We use k-means clustering. Once we're satisfied with how this looks, we'll save the impulse, and then we'll proceed on to the next step, which is to perform feature extraction out of the data that we have uploaded to our platform. And so, we can apply different DSP processing parameters here to our data. And we can, of course, save those parameters. Once we save these parameters, we can then turn to generating the features from our data sets. And we provide a visual explorer as well of those features. So as you can see here, we have the 3 different classes, features from the 3 different classes, house sparrow, rose-ring parakeet, and the noise. And you can see that there is definitely some separation between the 3 different classes, which means that a machine learning model should be able to pick up each class from the data set that we have. As I mentioned, we also have some, we'll get to the statistics in the next screen. So once we've generated our features, now it's time to train our model using the neural network. And so here we have basically some preset architectures using 1D or 2D convolutional neural networks. And we can experiment with the different parameters. For example, the number of training cycles can generally improve the accuracy or performance of your model. So in this case, we have a pretty good accuracy here. We've got our standard confusion matrix that will show you, as well as the statistics that I mentioned before in terms of on-device performance. So again, this is exactly how much RAM and ROM is going to be used in your project. And it takes 18 milliseconds, not a lot of time at all, to perform the actual inferencing. You can customize the different layers in your neural network. And we also offer you the flexibility to go into what we call expert mode, which allows you to edit this Keras block in Python as you see fit. So if you wanted to customize it, if you're a Keras expert, you can do that as well. Most people, of course, start with the visual mode. One unique feature that we have here is, again, when I mentioned about managing your MLOps pipeline, one of the very important things is to have different versions of your neural network classifier as you're doing experimentation as testing. So this is a feature that we recently released, which it allows you to experiment with different versions by cloning them and managing them. And so there could be times where I want to experiment, hey, okay, what happens if I bump it up to 200 training cycles? What does that do, right? So, basically it will pull up all of those parameters and then provide the training performance on that. So I can go back and forth between different versions as I'm experimenting with each of these different knobs. So I'll never lose my work, essentially, and I can always go back to, let's say, the one where I had the best performance. So this is a real handy feature as you're developing your model. And once we're happy with the performance of the model, the next option is, of course, to validate the model. And there are a couple of tabs for that. One is which we'll show right now, which is the live classification. So this is where I have the DK set up, and basically I can sample audio live from the DK. So this is connected using our Edge Impulse daemon. What I use typically is YouTube is good for everything. So here I found a video that basically is what rose-ring parakeets would make in terms of calling sounds. So I use this to test my model. So what I'm going to do is say start sampling. I'll click this, and once it's started, I'm going to hit this. So the device itself has captured that audio sample, and now it's, of course, the audio samples are buffered on the device, so it does take a little bit to actually send that up to our studio. But once this is done, it will actually classify that data sample, and we can look at the results. Yes, so it's picked up 5 counts of the rose ring parakeet just from that audio sample, as you can see here. And so this is for the entire 6-second data sample. And so basically it's seen 5 instances of that through the windows that we've provided. So each window is 500 milliseconds, as we've defined before in our impulse design. So this is how it's doing the count. So there, it's successfully, from that audio sample, we've basically successfully detected a rose ring parakeet. Now, in terms of deployment, once we're happy with how the model performs, oh, I forgot to mention our model testing page. Let me do that real quick. So this is kind of a quick interface for doing some testing. So if you have a lot of different test data samples that you have already imported, you can basically run through them in like a batch form. So select, like, let's say all of them, and then select, the ones that you want to test that you've already preloaded into the system. We've got a lot of test data here, so I won't do that because that might take a while. Versioning is a really good thing for managing your ML pipeline. So you don't want to lose all of the settings you had before, like in case you're doing a lot of different experiments. So you can actually save your entire project so that you don't lose anything. Like, for example, if you added more data in the future to see how that affects your model performance, maybe it might make the model perform better, maybe it might make it less, you don't quite know. So you definitely want to save your work. We allow you to do that through the versioning tab. But probably the most important thing is the outcome itself, which is the end result, which is how can I deploy this to my embedded device? You can deploy this as a C++ library, which has no external dependencies, Arduino or STM32, Simsys pack, or even a WebAssembly pack if you're doing some validation using some web interfaces. So this basically wraps up our Edge Impulse SDK as well as the model, the trained model itself. And then this is something that you can include into your standalone inferencing project. If you're looking for a streamlined user experience as we described, you can of course build this for the different Nordic DKs here. And what this will do is output a binary file that you can just drag and drop onto the device. So you may be familiar with the J-Link interface that exposes essentially a user drive on your system, like a thumb drive. And this is what then gets dragged onto that to update the device with the firmware. Yes. Okay. So that was the audio classification one. Now let's show you the second part of the demo, which is the gesture recognition. So for that, I'm going to go back to, let's see how we're doing on time here. Okay, we're doing good. This is the part where we're going to show streaming the results over BLE. Okay. So hopefully everyone can see my screen mirror here. Fire up the NRF toolbox, and then go to our Nordic UART service. Connect to our DK. So here we found the Edge Impulse DK on the 5340 here. So we'll connect to that. And then I'm going to load my menu preset that I've saved here. Okay, great. So what this allows you to do is via BLE, you can actually run the inferencing, start the inferencing. We have developed a serial protocol that uses a classic AT command interface. And so what I'll do here is first actually interrogate the device, and we'll be able to see the results on the logger here. So one of the things we can do is get the info about the device. So if I hit number 2, I'll be able to get information about the device itself. So here's the MAC address, the type of device that it is, and of course, a version of our AT command set. And we can start the actual inferencing by saying AT run impulse. This starts the inferencing and starts streaming those results over BLE, which is really cool. And I can start moving the board, doing a wave motion right now. So you can see that being picked up here. And then I'll do up, down, for example. So you can see up, down being classified and streamed across BLE. So there you go. That's an example using our 3D accelerometer and being able to share that information across BLE. And once you get it to that point, then you can start, basically taking it from there. Okay, so we'll stop that inferencing. Yep, so we've stopped the actual inferencing from happening. So it's really cool. Through the Nordic BLE UART service, you can actually actuate and stream the results, which opens the door for lots of different applications. So that concludes the demo portion. We hope this has excited you and inspired you to try different things, and also realize different IoT applications with embedded machine learning with Edge Impulse and Nordic.